Okay, this is a lesson on solving rational equations. Our first rational equation is 3 over x minus 2 over x plus 1 equals 4 over x. The first thing we're going to do to solve this equation is we are going to subtract the left side by creating common denominators. And we can tell that the common denominator for this problem is going to be x times x plus 1. So this fraction needs an x plus 1. And the second fraction needs an x. And that's going to give us 3x plus 3 over x times x minus 1 minus 2x over x times x minus 1. And that still equals 4 over x. When we subtract, we're going to get 1x plus 3 over x times x minus 1 equals 4 over x. Once we have added or subtracted anything in our equation and we have one fraction equals one fraction, now we can just cross multiply. Okay, so when we cross multiply, x times x plus 3 is going to give us x squared plus 3x. And then, well, we know that this is going to be x squared minus x, and x squared minus x times 4 is going to give us 4x squared minus 4x. When we solve this equation, we're going to subtract. I'm going to move everything to the right side because I have a higher leading coefficient over here. So I'm going to subtract x squared, and I'm going to subtract 3x. And that's going to give me 0 equals 3x squared minus 7x. Now, I need to factor 3x squared minus 7x, and the way I'm going to do that is by taking out the greatest common factor, which is x. So now I have 0 equals x times 3x minus 7. I'm going to set each of those equal to 0, each factor equal to 0, so I'm going to have x equals 0, and obviously that's going to be one solution. And then I'm going to have 3x minus 7 equals 0. And that's going to give me x equals 7/3. Now what we have to do is we need to take these two possible solutions and go back and check them in our original equation. Because we are dividing by both x and x plus 1, we have to make sure that our solutions don't result in dividing by 0. Now you can see that we have a solution of x equals 0. If I were to put x equals 0 in for x here or here, I would get 3 divided by 0, and that is bad. Can't divide by 0. Same thing here, 4 divided by 0, bad. Therefore, we know that x equals 0 is an extraneous solution. Now, if I put 7/3 in for x, well, I can divide by 7/3, I can divide by 7/3 plus 1, and I can divide by 7/3. So 7/3 is my only solution. All right, number 2. I'm going to start the same way. I'm going to create common denominators. So I'm going to put this 5 over 1, and I'm going to multiply it by x plus 3 over x plus 3. And I'm going to have 2x over x plus 3. Now, what I'm really going to do is, guys, I'm going to distribute this as if it was a -5 and make this an addition problem so I don't forget that I'm subtracting the 5. So I'm going to have plus -5x minus 15 over x plus 3 equals 1 over x plus 3. When I add together the left side of my equation, I'm going to get -3x minus 15 over x plus 3 equals 1 over x plus 3. Now, I could cross multiply at this point, but that's going to create a lot more work for myself. I notice my denominators are identical. If you are in a situation where you go to cross multiply and the denominators are identical, what I can do is I can equate the numerators. So, let me make some white space here. I'm just going to say negative 3x plus minus 15 equals 1, because, I mean, if I have a numerator over a denominator equals a different numerator over the same denominator, obviously my numerators are equal. I'm going to add 15, I'm going to divide by negative 3, and I'm going to get x equals negative 16 thirds. And when I check, if I do negative 16 thirds plus 3, I don't get 0. So I'm okay, and that is my solution. Okay, number 3, we again need to create common denominators. I'm going to first look at my denominators that I have and see if there's anything I can factor. And I see my last denominator can be factored as x plus 1 times x minus 1. And that is also my least common denominator. So the first fraction needs x plus 1. The second fraction needs everything. So what I'm going to do to make it easier, in the numerator, I'm going to write x squared minus 1 because that's the product, obviously, of these denominators. And just because I'm low on space, I'm also going to do in the denominator x squared minus 1. Now when I distribute, 5x times x plus 1 is going to be 5x squared plus 5x over, and again for space, I'm just going to write x squared minus 1. Now I'm going to distribute this as a negative 2 and make it addition, so it's going to be plus negative 2x squared plus 2 over x squared minus 1 equals 14 over x squared minus 1. And I'm in the same situation I was in the last problem. My denominators are all identical. If I have a group of fractions that comprise an equation and all their denominators are identical, I can equate the numerators. So I'm just going to kind of take the numerators here. On the left I have 3x squared plus 5x plus 2, and that's going to equal 14. I'm obviously going to subtract 14 from both sides. Now, I want to see if this factors first before I go to the quadratic formula. So I'm going to do 3 times negative 12, and that's negative 36. I'm going to split the middle. And are there numbers that add up to 5 and multiply to negative 36? Well, let's see. 2 and 15, 16, 17, 8, no. 4 and 9. Oh, 4 and 9. So it's going to be 3x squared plus 9x minus 4x minus 12. Equals 0, group, take out 3x, x plus 3, take out negative 4, and we've got x plus 3. Now we're going to have 3x minus 4 times x plus 3 equals 0. And we are left with the solutions of 4 thirds and negative 3, both of which work, because the only things that would not work here would be negative 1 or positive 1. So both solutions work. Alright, number 4 is a lot like number 3. So why don't you, I'll work on it silently and you work on it, and then you can look up and check your work. And I can equate my numerators because the denominators are all the same. Now I'm going to split the middle, but you could obviously guess and check. Plus 2, take out a negative 1. Okay, if you're not ready to see the final answers, pause the video, because I don't want to ruin the surprise. And our solutions are x equals 1/2 and x equals negative 2. And I go do a quick check, and the only things that would not work in this equation are 1 or negative 1. Alright, for 5 and 6, what I want you to do is pause the video, write it down, and work on them yourself. Alright, for number 5, you should get negative 1 and 3, and they both work. And for number 6, you should get negative 3 and 8, and they both work. Alright, now sometimes it's just going to flat out tell you to cross multiply. We're going to do 1, we'll leave 8. You can do that one on your own. So if it just says solve by cross multiplying, you can obviously just go straight to the cross multiplying step. So we're going to have 3x squared plus 9x equals, now I'm going to be really careful here to multiply correctly. So 3x squared plus 9x equals 2x squared. This would be minus 3 plus 8 is going to be plus 5x minus 12. So I'm going to pull everything to the left side because this is a higher leading coefficient. We've got x squared plus 4x plus 12. Uh-oh. That's a problem. That does not factor. Whatever shall we do? Well, we can complete the square, or you could use the quadratic formula. Honestly, I think this is a good candidate for completing the square, and here's why. This is a 1x squared, and this is a 4, which is an even number. So I'm going to subtract the 12 from both sides. Oops, that's 4x. I'm going to add b over 2 squared, which is 4. This is going to be x plus 2. This is going to be x plus 2, take the square root of both sides, equals plus or minus root negative 8, which you all should know is plus or minus 2i root 2. And we subtract 2 from both sides, and we get negative 2 plus or minus 2i root 2. That's an awesome answer. And obviously, it's not negative 3, which would make this 0, or negative 4, which would make this 0. Right, so you start number 8. I will work silently, so you can look up and check as you need. Pause the video if you're not ready. The answers are negative 5 and negative 1, and both of them check. Neither of them are extraneous because neither of them make one of our denominators equal to 0. So what I would like you to do right now is turn and look at worksheet 132 in your packet. And if you need to check your solutions as you work, here they are. Actually, I'm sorry, you're going to work on worksheet 129. No, wait a second. Yeah, let's work on 129 in class and then 132 for homework.